So record on this computer. All right, so we are recording live at this point. I got everything but a pen. I could use my nice pen, but I don't want to burn all my ink up. I'm using free pens to do this part. All right. What are we doing today? Last time we did quite a bit last time, right? That last lecture is pretty intense. But it's really good information. We talked about several things. We talked about multi-view drawings, right? Within multi-view drawings, we talked about, excuse me, we talked about orthographic projections. We also talked a little bit about pictorials. We talked about some parallel projection types of pictorials. And I said most of the time we'll probably work with isometric. We said isometric is, and you don't have to use this grid paper, but this grid paper with the triangles on it, that is isometric grid paper, right? So that allows you to draw. It's a little easier to draw in 3 dimensions if you want to draw in an isometric configuration using that grid paper. If I don't have grid, I like to personally draw in a diametric orientation a lot of times. So I will draw in either one of those. There is a trimetric, and I drew probably the worst possible variety of a trimetric last time. There's infinite number of diametric and trimetric, but of course isometric is where roughly X, Y, and Z, your 3 axes, your 3 parallel axes, are all at equal angles from each other. Diametric can take a number of forms, but the most common one I like to use would be where Z, your vertical, and Y, your left and right, are at 90 degrees. Then lines that are vertical, I can draw up and down. Lines that are left and right, I can draw left to right. And then the ones that are into and out of the page, the X direction, that's where the angle there is the same. So diametric simply says that 2 angles are the same. Right? Any configuration where 2 angles are the same, this one doesn't have to be 90. This is the version, the flavor of diametric I highly recommend because it's easier. Most of us are drawing you can normally do okay drawing something left down, something left right. And then the only one you got to worry about is the one that should be into and out of the page. Draw off. Yes.
What sort of advantage would there be to draw any other way?
If I had it, if I wanted to, pretty specialized situations, right? Pretty specialized situations. It's really where I'm really trying to show. I'm trying to rotate the object in such a way that I'm really trying to show a lot of detail in one specific location, and then my normal X and Y axes just happen to end up getting oriented in a different direction. Right? So it's, and sometimes, and normally we're just going to do that in the computer. We're going to have the object in SolidWorks and we're going to rotate it. We want to show just this one particular area, right? And we'll let the computer do that for us because it can generate infinite views. Okay. But sometimes we would have to draw something by hand. Right? I wouldn't personally, right? Unless it's just something really specific I'm trying to illustrate. That's a good question. When would we use any other orientation? I don't have a great example right off the top of my head, except if we're really trying to show multiple views of one object, then several of those other 3-dimensional views might be in various varieties of these different flavors. Okay. Other questions? Cool. What else? Right. And so again, if you're, in layman's terms, the orthographic projections, those are the 2-dimensional views. The pictorials are the 3-dimensional views. Right. And they're all 2-dimensional because we're showing these on 2-dimensional media, paper or computer monitor or device monitor. So they're all 2-dimensional images. It's just the pictorials are where we're trying to draw it where it appears 3-dimensional, even though it is 2-dimensional. And to do that, we have to figure out how do we want to show the axes, the orientation of this object in such a way that it appears three dimensions. Okay, but with a two-dimensional projection, I don't have to sacrifice those angles. I don't have to worry about what angle am I showing that. I can just show it right directly to scale where all the angles are correct, but I can't show the entire object with a two-dimensional. And that's where the idea of multi-view drawings comes in, is multi-view drawings allow us to communicate all of the information about, let's say that I just have like a cylinder, which this is a terrible cylinder, but roughly a pictorial of a cylinder. Okay, what does this look like from, if this is the orientation, what does this look like from the front, top, and right? Well, the front would be, if I'm looking, if I'm using an isometric orientation here for this drawing, the front would basically be right in the X direction, looking right at this thing at the eye level, looking down the X axis. And if I'm looking at this thing right from the X axis, all I'm seeing is a circle. It's a terribly drawn circle. Terribly drawn circle, but you guys get the idea, right? So if I'm looking at just, again, right from the front down the X axis, if you will, all I'm going to see there is a circle. So, okay, well, is it a spike? I'm seeing the backside of the spike. Is that a cylinder? What is this? Well, you don't know from one view. That's the disadvantage of a three-dimensional object represented in a 2D view. One view doesn't tell you everything you need to know. I need more views. So if I look at this thing right straight down, basically down the Z-axis, and again, you want to line these views up. The width of the front is going to be the width of the top. So if I'm looking at this thing right straight down, I'm going to see the outline is going to be rectangular. Now, again, if I drew some shading, if I say, well, the sun's over here, so this side is light and this side is shadowed, I can try to communicate to the viewer, hey, this isn't just a flat rectangle. But if I don't, short of adding any shading and shadowing, which I'm not going to ask you to do, there's no way to look at this one view and say, well, that's circular. You don't know. That's, again, the disadvantage of two-dimensional views. It doesn't tell the whole story. We put the three together to tell you everything. Yes?
Is there a standard types of shading?
Yes. And you're exceeding my knowledge limit there because I never use them. I just use multi-views and then I don't have to worry about shading. But yes, there are, but we'd have to go look it up. Yeah. And then again, these two views would be enough for this simple of an object. But if we went ahead and drew the right view, again, we line these up. You don't have to draw these dotted lines that I have here. I'm just doing it for emphasis. Line these up, otherwise it's wrong. Right? If I'm drawing a multi-view drawing, I'm going to go to the trouble of drawing more than one view of this thing. Make sure they help each other. Line them up, because the width of the top is the width of the front, and the height of the front is going to be the height of the right. And this is what we're really going to focus on a lot today. Right? Is how the three views work together. Right? But if I'm looking at this thing from the right side, again, I'm just going to see an outline of a rectangle. Make sure you line it up where your dimensions work together. Roughly this, I wouldn't normally recommend you do this, but you can, just to show emphasis here, this width should be this height. Okay, when I put a ruler and I'm actually drawing this to scale, right, this linear dimension here from here to here should be the same as this linear dimension from here to here. And those are the same. We're communicating the same information. So all three of those views should work together. Okay. Questions so far? Okay. Again, complete review, just quickly. That's what we spent almost 2 hours talking about last time. Right. We talked about a lot more than that, but that's kind of in a nutshell what we're looking at. All right. So again, let's continue on with that discussion just a little more today. Let's talk about different surfaces that we might encounter. The first one we talk about is a normal surface. So normal, perpendicular, and orthogonal all refer to essentially the same thing, things that intersect at 90 degrees. Right? That's the reason up here we say these are orthographic projections. It's taken perpendicular to the plane being drawn. Normal, orthogonal, and perpendicular are all referring to the same thing, things that intersect at 90 degrees. A normal surface, which is the most common surface, it is either vertical, up and down, or horizontal in 3 dimensions, right? In real world space, real space. These are things that are either vertical or horizontal, meaning they intersect at 90-degree angles. I'm digging around, find something. Have some normal surfaces on. This is okay. Right? So here's an object here. Right? So you can see these all intersect at 90 degrees. These are all normal surfaces. Okay? Square surfaces, if you will. These would be cylindrical surfaces. I've got a normal surface right here, though. And then this would be a cylindrical surface. So there's an object that's got kind of a variety there. Normal surfaces, they all intersect at 90 degrees. They're either horizontal or vertical. And that can come in a variety of flavors, but they can all intersect. They all intersect at 90 degrees. So here's what happens when I draw a normal surface. Appears as a line or surface in an orthographic projection. Orthographic projection. A normal surface is either going to appear as a line or a surface. It's doing okay today. Thank you for checking. Yeah. So normal surface, vertical, horizontal, appears as an orthographic, appears as a line or a face in an orthographic projection. Okay. So let's do something. Let's draw a multi-view drawing here of a simple enough object. I'll show it to you and then we're going to draw it. Okay. We're going to draw this guy and we'll draw a multi-view drawing of this guy. So kind of an upside down L shape, if you will, in 3 dimensions. All right. So page 1, this is page 2. So again, I'm going to draw some variation of this guy. Probably not going to be that good, but we'll draw a variation of it. I'm going to draw the top face. I'm going to draw it in an isometric, roughly isometric configuration. So again, I like to draw my X, Y, and Z axes over to the side there because I'm going to draw lines that are parallel to those. All of the lines of a normal surface will be in one of those 3 directions. Okay, it'll either be an X, Y, or Z. And this is roughly how I'm going to draw this drawing here. It's roughly isometric. It's not perfect, but it's pretty close. All right, so I'm going to draw the top face. All right, so I'm going to have this long line coming down the X direction. Again, I like to dot it out first, and then I can go back and fill it in later. But if I dot it really light, then if I mess up, if I'm on pencil, I can just erase it. All right, so I've got a really long line down here in the X, maybe 2/3 of that length in the Y. And then maybe 1/3 of that length down in the X from the end of this Y line, 1/3 down in the X here. And then maybe 1/3 back up in the Y. So again, I'm trying to draw lines that are parallel to the X and Y's up here. And then I'm gonna just from here, I'm gonna extend in the X direction. And then I'm gonna get these two to join. So from here, I'm going to dot back up in the Y. Don't try to force your intersection. Keep your lines parallel and erase the part that you don't need. But to find an intersection, just extend the two past each other, and where they intersect, that's where you'll draw to. Again, try not to force the intersection, try to force parallel lines. So that gives me the outline of this top face. I'm going to go ahead and make good, solid, thick, visible lines for that. Again, a couple passes will make a solid, thick line. Doesn't have to be perfect. We're just trying to communicate roughly information. And then I'm going to draw faces. So I've got a face here, I've got a face here, and a face here. So we need to try to figure out how those faces are going to get constructed. However you see to do this, go for it. I'm just going to explain how I'm seeing it and doing it. So from this corner on the far left, I'm going to dot a line straight down the Z. I'm going to draw another line straight down the Z from here, roughly about this length here. I should say this length here, but down in the Z direction. And again, don't try to force the intersection of one to the other. Just dot lines parallel to these other. And I'm going to dot a line in the Y direction, parallel to the Y. If I happen to get it to match the other line, fine. If not, keep extending both of them until you find the intersection. But again, try to keep your lines parallel. That is our goal here. And once you've got a face set in, just solid it up. If you want to skip ahead and do other faces, go for it. I'm just going to kind of explain what I'm doing as I go. So I'm going to dot a line down from this middle. From this point down here, I'm going to dot a line up in the X direction. Try to find where those two intersect. And then once I find the intersection, I can solid those lines in. Dot a line down from here. From this corner, I'm going to dot a line down in the Y direction. Find the intersection, make it solid. Try to channel my inner Bob Ross here. Got a little line here. He's got a friend that comes back this way. They come together. It's a happy little accident. Some of you guys have seen Bob Ross before. If you've not seen Bob Ross, go look him up. Dude with the afro, white dude with the afro paints, Bob Ross. Okay. All right. So nice, rough shape, isometric pictorial. Let's make a multi-view drawing of this guy. Okay. So what does that mean? It means I need to draw front, top, and right that work together. We'll go ahead and draw the top first. You can draw the front or the top or the right, whichever way you want to go. We're going to draw the top. That's looking straight down at it this way. Okay. I'm going to line it up this way. So the top is just going to look like an upside down L. Now, I've learned over the years, I could take a ruler to this and get my lengths right, and it really just kind of slows me down, and I'm not sure it, if I'll put it this way. If this was an actual object I was trying to copy and make a good drawing of, I'm taking a ruler, I'm measuring this, if I'm trying to draw this guy, well, I'm going to measure this line, and then on my 2D drawing, I'm going to draw a line this length. Okay. On a 2D drawing, I'm going to draw the other line this length. I'm actually going to make these right. If I'm just drawing an arbitrary object for demonstration, I've just learned over the years, if I put a ruler to each line, it really slows me down. You guys get tired of watching me put a ruler to it. Does that make sense? When you're drawing these, if I'm drawing, and I'm going to ask you today, I'm going to give you some objects. I'm going to ask you to draw orthographic projections of some objects. Take a ruler to those, and then take, measure this, and then take a ruler and draw this length, or to scale. Okay. So I'm not using a ruler here, but I'm asking you on your assignments, use a ruler on those. Does that make sense? We good with that? Okay, awesome. So I've drawn my top view. This is looking straight down this thing. We're seeing an upside down L. And again, we want to line these drawings up. If we're going to go to the trouble of making them, let's make sure they help each other out. So I'm going to draw my front down here. The width of the top is going to be the same as the width of the front. You don't have to draw these dotted lines. If you line it up, if you got grid paper, just, have it, take the lines on the grid and line up the front down here. That's okay. So the front, when I look at this thing up the x-axis, basically, that's going to be my front views, up the x-axis. I'm going to see this face here, and I'm going to see this face here, but the outline is basically going to be a rectangle, and it's the same width as this up here. So I've got a rectangle, the same width as the top view. The outline is going to be a rectangle, a little wider than it is tall. But again, when I look up the x-axis, if I get eye level with this thing and look up this way at it, I will see two different faces. So basically right about in the middle, there'll be a line dividing this thing. Now from this view, I can't tell you what those two faces are or how they interact with each other just from this view. That's what the other views are for. Right? Talked about that several times. Talk about it many more, I'm sure. Now again, to draw the right, I'm going to make sure the height of my right view is the same as the height of my front. They need to work together. If I'm looking up the y-axis at this thing, that's the right view. Right? So I'm looking up the y-axis. Well, I'm going to see this face here. I'm going to see this face here, but the outline again is going to be a rectangle. Now this rectangle is going to be wider than the front view was. The overall outline is going to be a rectangle. Now again, there will be two faces I can see here. There's one here, there's one here. What I'm going to have is one face is not going to be as wide as the other one. One face is almost square, if not exactly square. And the other one's going to be a longer rectangle. Okay. Now, a few things, again, you don't have to draw these dotted lines, but just to show you, you can put a dotted line in here and say, well, this is, right? These lengths should roughly match each other. This height should match this width. If you're taking a ruler to these, they will. Okay. Okay. So these are all of these are, again, what we're talking about here is normal surfaces. All of these are normal surfaces. These are all intersecting at 90 degrees with each other. They're all either vertical or horizontal. If this thing was a real object, I should 3D print this so we can show it. If this is a real object in front of us, all of these are either vertical or horizontal. They all intersect at 90 degrees, and they all end up being either lines or a face when we view them in front, top, and right. Let's make a table. Let's talk about, you know, how these work together. So if we make a quick table here, I've seen this table in an older text. I haven't seen it in the text in a long time, but if we talk about normal surfaces, we try to categorize them. They follow a consistent pattern. Normal surfaces. I'm going to make a table here. I'll show it to you. We're going to make this table. It's four rows, 3 columns. Right? Top row is real thin, and then larger boxes for the next 3 rows. So it's 3 columns wide, 4 columns long, or 4 rows long. First row is kind of short. I'm not going to close the bottom of this off. I'm going to leave it open at the bottom so I can keep moving down as I go. But the top row is going to be kind of short. There's going to be 3 roughly equal columns here. Yours doesn't have to be perfect. It's your notes. And you don't even have to take notes. I highly recommend it, but you don't have to. All right, so we're going to do a front column. We'll do a top column, and we'll do a right column. All right, so if I've got a surface in the front projection, where does that surface then live in the other 2 projections? Well, so here I've got, if I say this is A and this is B, and again, you label your faces if it helps you. I don't require it, but it's a nice tool to do. These are my faces in the front, and so again, looking up from the X, that's my front view. So this would be A, and this would be B. Okay. Now, again, we're filling this table out. So if I've got a face in the front, that's A and B. Where does A and B on the top projection. So where would A be on the top projection? Pointing down, right? It's the bottom. It's right here. And again, you see how these line up. That's the reason we line these drawings up as they work together. This should be A right there. And so this lines up. This should be B right there. These are lines. These are horizontal lines. So if I have a face or a surface in the front, it's going to be a horizontal line in the top. Okay, and what about in the right projection then? So I've got A and B are my surfaces. A and B are my surfaces in the front projection. Where do these guys live on the right projection? We can start with an easier one. Where does A live on the right projection? Where's A on the right projection?
Vertical.
Exactly. Both kind of pointing right up. A is this vertical line all the way to the far left. How do we know that? Well, if I'm looking this way at the right, you can see A is right here at the far left of the right view. That is this vertical line right there. And that means B being right here, and I'm looking up this way. That puts B right there in between the two. A and B are vertical lines on the right projection. So your surfaces, your normal surfaces, if they're surfaces on the front, that means they're a horizontal line on the top, and they're going to be a vertical line in the right. Okay, let's go to the next one. So let's say I've got a face or a surface in the top projection. Right, and this is why I said if you wanted to wait, if you don't want to finish that assignment 3, right, last time, the one I assigned last time, if you want to wait until we talk today and do it over the weekend, that's fine, because we're going to grow on what we did last time. So that's the reason I said go ahead and wait on that one if you want to. Try to get it done by Tuesday when we get back. And if you get the other one, if you get the next assignment 4 done by Tuesday also, that's awesome. If not, you have time, right? Just understand we're going to start working on SolidWorks, so we're going to start keeping adding assignments. So don't fall too far behind. But if you do, you can get caught up. All right, let's talk about faces on or surfaces on the top. Right. So what are my surfaces on the top? Well, if we say this is my surface on the top, that's C, or face on the top, that's C. Okay. Where is C on the front? Oh, you can't see the front. Where is C on the front? It's the top, right? It's the top view. And this one's not too hard because it's the only face I've got on the top view. That means it's going to be on the top. All right. It's going to be the one closest to the top. C is going to be this entire line across the top. It's one solid line. That's C. What about the right? Is it any different? It's the top. I've only got one face on the top. It has to be the top of the right also. That one's that. A lot of times when I've only got one face on a particular projection, it's a little easier to identify it on the other projections. Not always, but normally it's a little easier to find it. So notice that C on both of these, it's a horizontal line, right? If it's a face on the top, it is a horizontal line on both the right and the front. Okay. All right. Let's do the last one. Let's say if I want to look at a surface on the right projection. So the faces that are in the right, that's looking up in the Y direction. Well, that's going to be D and E, we can call them. So D here and E there. You guys are probably starting to figure this out, right? If I've got D here, where is, well, we could do D or E, but if I say, I think E is a little easier. If I say, where is E on the front face?
Right, vertical.
Yeah. And you can kind of look at the 3D. When I've got the 3D here, that helps, right? And when I look up at the front, E's over here all the way at the far right. That means and it's right next to B. So that means E has to be this vertical line right next to E. That means D is, you can see D is between A and B. Well, I've got a line right there between A and B. That means that must be D. Okay. So if I've got a surface on the right, it is a vertical line, an up and down line on the front. Okay. All right, and then we say, all right, well, where is D and E on the top projection? Again, you can kind of look at C here and realize E is over here on the far right of it. That's going to be this guy right here, this vertical line right there. Same thing here. D is going to be between A and B. Well, we said A and B is right there. D is in between them. That's this vertical line right there. So it's also, if it's a surface on the right, it's also a vertical line on the top. That's a nice handy table to have with you. Like I said, the other text I've looked at, I saw this in a really old text. The first semester I taught this course was the text the previous instructor was using. And I've not seen any other text, so I was built. I think it's really helpful, handy thing to have. You don't have to have it with you everywhere you go. It's just once you've built it, you kind of have that knowledge now. You understand how that works. Okay, so whenever you're dealing with normal surfaces, keep this in mind. If I see a face on the front, can I figure out where that face is on the other projections? And that skill will help you then when you go from taking the 2D images and trying to construct a 3-dimensional image. The same rule applies. It goes backwards. So if I see a face on the front projection, that's going to be a horizontal line on the others. And again, that helps you kind of construct those 3-dimensionally. And if you're like me and need all the tools you can get when you're trying to draw from 2 dimensions to 3 dimensions. And that, like I said, that takes practice, and that's what we're here for. All right, let's talk about a couple other surfaces though, types of surfaces. That's normal surfaces. Now we can also encounter, there's 2 other categories of surfaces I would suggest we talk about. Sorry, I need a bit of water there, else I'll lose my voice. I can tell it's starting to go. If we talk about inclined surface, and if we talk about an inclined surface, let's see if I've got something handy here. Right. So example of an inclined surface here, something that this be a normal, right? So you can see this object here. I've got a variety of surfaces here, but you can see this normal surface, they intersect at 90 degrees. This one doesn't intersect any of the other surfaces at 90 degrees. That is what we call an inclined surface, like a ramp, basically. That's an inclined surface. So an inclined surface, it will appear as a face in at least 2 orthographic projections. Whereas the normal surfaces, I see a face, and if it's a normal surface, that's the only place I'm going to see that face, is that one projection. It's going to appear as a line on the others. An inclined surface, when you just look at 2-dimensional images and it's like, wait, which face is this? Well, it can actually be a face in 2, and in the extreme situation, it can be a face in all 3, front, top, and right. Right? That's kind of an odd situation, but it does occur. If I've got like inclines coming off of a pentagon, or a hexagon, or something like that, then some of those are going to come off at different angles. So it's not going to be perpendicular to at least one surface. But it's going to appear as a face in at least 2 of these projections. It may appear as a slanted line in the 3rd projection. most of the inclined surfaces we'll deal with will appear as a line in at least one projection. But again, it's not hard to imagine situations where it's a face in all three. Okay. And then you will have some slanted lines somewhere within the diagram that will kind of give it away that you're dealing with an inclined surface somewhere. So when you see a slanted line, that means it's not vertical, it's not horizontal. Show up in at least one projection. That's a dead giveaway. Hey, I've got something in here that's not normal, literally and figuratively. Okay. So we can draw this guy real quick. All right, we'll draw this guy very similar to what we just drew, but we've got a slanted surface on an inclined surface. Let's draw that one. All right, we'll go to the next page here. Just grab this page off. I used to teach with a document camera a lot. Not this particular model. The ones I'm used to have a zoom in and zoom out feature, so it's a little easier to work with. But all right, so let's, again, we're going to draw this. Here's what I'm going to do. I'm going to kind of rough this in, draw isometric pictorial first, roughly isometric pictorial first. So I'm going to draw my reference angles over there. I'm going to dot this in very lightly because I'm doing it in pen and I can't erase, but I will basically need to ignore some of these lines. I'm going to dot very lightly, essentially the outline of what we drew last time, because it's a similar shape. All right, so I'm going to dot in this upside down L shape and very, very lightly going to dot that in. Right. And then here's what I'm going to do. I'm going to draw this as an actual solid face. And all of those, again, this is what we're drawing. So I'm basically drawing this face, and I'm going to draw these faces also. Okay. And then we'll figure out what to do with this guy. All right, so I'm going to draw this face. I've drawn this face in, and then we're going to draw a face right here, kind of roughly a square face right there. Some vertical and an X direction line there. I'm going to draw a face right in here, I think. Let's see. No. I'm going to dot. Let's find my intersection here. So I'm going to dot here, roughly to this point, and I'm going to dot out here. And I know my intersection is going to be right down there. So I've kind of found this corner right down here. So roughly from this point down and extend out to roughly where this would meet down there. I need to find that corner because this line right here is solid. So I'll go back a little darker and then darken it in. Okay. And now I've got a solid line from here to here. Now, what I need to do is from this point right here to this point down here, I need a line from here to here. It's at an angle. So I'm just going to very gently dot it in. And see if I got it. It looks like I got it pretty close to the right on the first pass. I'm going to go a little darker dots. So I kind of got how that's going to go. I'll fill that in. It looks like I should be able to actually draw this as a solid line right there. And then, so I'm going to dot from here. I'm going to dot up in the Y direction, parallel here. I'll go past a little ways. And then from this corner, I'm going to go down. So this line is solid. Now these lines up here, these gently dotted lines up here, we're going to ignore those because the only one that's solid is from this corner right here to this one right here. I'm going to very gently dot in a line to get me from here to there. Just going to take my time, go along that, make that solid. That's how I do it. Take your ruler to that, and you can get a nice, good, solid line right off between those 2 points. A variety of ways you can do it. So just kind of quickly by hand without much aid. If I'm sitting trying to explain this to somebody, I need to draw on a napkin. That kind of gets us in the ballpark. That's our goal with the hand drawing, is get you to where you can communicate roughly with somebody if you need to. All right. So I've got an inclined face and I've got a handful of normal surfaces. So if I draw top, front, and right for this guy, well, if I view this from the top down the z-axis, again, the outline is going to be this upside down L, similar to what I had in the last multi-view drawing we did. Okay, I've actually not got my proportions right there at all. Again, I'm just for demonstration purposes here. Okay. Now I do have two different faces, so I'm actually going to distinguish and say, hey, these are different faces. These are not the same. There's this continuity there. One stops, the other one begins. Now again, from this view, you can't tell whether these are both normal or which one's inclined. We don't know. That's the reason I need more than one view. Okay. But again, because an inclined surface can appear and will appear as a face in at least two projections. This face, if I call this face A, this is face A here, and this is B, we'll call this one B. All right. Because A is an inclined face, it's going to appear as a face in more than one projection. So if I look up the x-axis, draw my front projections, I'm going to line that up with my top here. I have the same width. The outline is going to be this rectangle, slightly wider, roughly 2 times wider than it is tall. And again, you can see, you can also line up here and know that you're going to have something in kind of right in the middle here. Well, if I look straight at this thing, okay, the faces I'm going to see part of A here, and I'm also going to see this surface right here. We'll call him C. So I'm going to have two faces. I'm going to have C right over here, the normal surface, and I'm going to have this inclined face A. I'm also going to see in the front projection. Then if I look in the right projection, up this way, well, again, the front is going to have the same height as the right. But when you look, right, if I look up the right face, up the y-axis here, right, this being X, Y, and Z again. If I'm looking up the y-axis, I'll see this face here, we'll call him D. And I see this triangular face here, we'll call him E. All right, so I see a square over here to the far right, and I see a triangle kind of next to it. So I'm going to draw a longer line on the bottom. Go up, same height as the front. I'm going to have roughly a square over here to the far right. And I'm going to have this slightly long triangular face here. This being D, this being E. All right. And again, whenever you see, the whole goal here to talk about is whenever you see somewhere on your drawing, you see something that is not a horizontal or vertical line, that's going to be a giveaway. Somewhere in here, I've got some type of an inclined surface. This is a simple one because it shows up only as a face in only two, right? And then it's just a line in the third one. Okay? But the same rules apply. These others, all these others, B, C, D, and E, these are all normal surfaces. So that means they show up as lines in the other projections. Okay? So E there, D there, okay, C being right here. Right, that would put C right there, and of course B being there, and B going across the top up here. Questions, comments, complaints? We'll talk briefly. We're not going to do a lot with these, but it's worthwhile to mention cylindrical and spherical surfaces. And cylindrical and there's a key in there, spherical surfaces. Simply put, these are going to appear as a circle or arc in at least one projection. So I've got some spherical surfaces there, you guys can see. Right, so if I'm looking straight, if I look this way, right, if I say that that's my top, or I could say that's my front, I could say this is my front right here. Right? I'm going to see this circle. I've got a smaller circle I would need to highlight as a dotted line underneath to say I've got a smaller circle underneath that's hidden, you can't see from this view. And then I could draw the outline of this square behind it, but I've got a square outline that you can't see from this view either. Okay, and we could show from this view. So notice these spheres, when viewed from these directions, now the lighting and the shadowing kind of helps us here, but you can see, and the fact that these are 3D printed, you can see some, you might be able to see some of the striations in there too. But you can see that these roughly are rectangular spheres. I'm sorry, cylindrical features tend to be rectangular viewed from two different projections and a circle from the third. And spheres just depends on how they're, or portions of a spherical surface. It just depends on which direction they're oriented and how you're viewing them. But you'll see some arc in at least one or two projections. Normally spherical, they'll show as arcs or circles in multiple projections, if not all. It's a complete sphere, it's going to show up as a circle in all directions. Questions for me? Very rarely do I ask you to do a lot of spheres. If I do ask you to do spheres, it's or cylindrical, it's pretty rare that I ask you to actually draw three-dimensional images of them. I might ask you to draw a circle here, projections of a spherical surface or projections of a cylindrical surface. Occasionally, I'll ask you to do one or two here and there, and I don't expect great work there. But when you're doing it by hand, we do want to have an understanding of what the computer's doing for us, and that's our whole goal. All right, guys, that is what I have. Questions for me? Okay, let's look at the assignment. I'm going to stop recording here, and we'll go look at the assignment.